We have from Chrome here. Last week I didn't make much progress in the Crimson front. I attended a local meetup of SIF and made a short speak regarding to the little progress on Crimson. And that's basically what I have. And I based on I'm looking at the benchmark of community centers, and it looks promising. And I think my next step is to either work on the SeaStor Rise RockCP, or try to start working on the preliminary design of SeaStor. That's me. Chen.
Yeah. I sent out the Alien Blue Style Rados Bench test result, and it seems when the TP thread pool number is true, it's better than the self-OSD default option. It's similar as the self-default option and better than the self-OSD if we set the thread, all the thread to be 1. So did you take a look at the test result?
Yes, I'm looking at it right now. By the thread pool number, what do you mean by the thread pool number? Is this the number of thread assigned to the
yes, it's the thread number. The thread pool will create how many threads in that thread pool.
So that thread pool is dedicated to the analyzed blue store. Is that true?
Yes. Yeah.
And then you do ping them to the core, which is not occupied the SeaStor.
Yes, right? I ping it to the currently hard coded to the CPU core 10, and OSD as Christmas OSD running on the core 0.
Okay. I see.
So when the thread pool number is equal to 2, in most of the cases it is similar as the self-OS default option set. Default option set means that a sync messenger and OSD shard number. A sync messenger is 3 thread. OSD shard number and thread number per shard totally may be maybe 8. I forgot. So that thread number is bigger than our Chromosome OSD. Only the first case for the write and concurrency is 1. The promise is worse than the self-OSD.
But it's almost the same as the classical OSD, right? Because I think the deviation is like less than 5%.
So then I will clean up the patch and do the modification according to the comments and Sam and Rados write on the comments and provide the PR. But I think because there are so many macro definitions changed, I'm not sure if you like to be merged into the Ceph.
Definitely, we need to merge it into Ceph, but we need to break it into smaller changes so we can help the viewer to get a better understanding of it.
I mentioned a few things on the PR that you could do to clean it up.
Yeah, I will modify it according to your PR, to your comments.
Okay, so once that's done, I think it'll be a lot cleaner.
Pardon?
I specifically mentioned that it's for every one of these files, we want to introduce like one specific macro header that gets defined one way or the other based on based on some compiler symbol. That will make it so that most of the files require really only one line change, and they don't need to be changed subsequently.
Yeah, I see.
So I think we can accomplish this with less. Basically, I think we can live with this if we change up the way it works just a little bit.
And so the next step is to support the FIO test. So currently we couldn't create an image, right? Couldn't map the image. So how many work left? How many work left to do the FIO test?
You mean the RBD backup, RBD engine, right?
Yeah, RBD image, something like that.
I assume that it's already workable at the current status using the memory store memory object store.
Yeah, so I think maybe the alien store, the interface maybe not enough if we support the image, something like that. So I don't know what kind of image interface I needed to do to support the FIO test. So I will do the investigation next step.
Okay. But presumably, if you implement all the interfaces required by filterized store, that should be ready to go, I think, for the FIO test. That's my understanding, at least.
Okay. So that's all from me.
Okay.
Thank you.
Thank you. Redek, how's it going?
Last week I was focused on scripting and particularly on testing. I made 2 lists. Let me paste the links. Here is the first one. It's about testing with 3 OSDs in a cluster. In comparison to the previous runs we made, we were after comparing to the previous runs we made, we were a bit afraid that there is a performance regression of Crimson, because we expected to see around 60,000 cycles per read, but the document shows there is 75 or something like that. But it was with 3 OSDs in the cluster. It's a huge difference from previous procedure that was about single OSD and single client. So I retested this scenario, and it turned out that in Crimson, actually there is no regression at all. We can see still 60,000 of IOPS. But in comparison to both the pre-OSD runs and the very old runs, we can see that classical OSD got significant speed up. In both pre-OSD in the pre-OSD run and in previous single OSD runs, classical needed around 200,000 of instructions per IO. However, it changed for one OSD scenario. It has changed recently. I made a bisect, and it turned it's related to your mutex rework, and I believe I know the reason. I have a hypothesis that the changes switched the default log dep handling. It turns out that previously, in June, we had even on production on release builds, we had the log dep available, and vstart turns it on by default. That's not the case anymore after merging the CEF mutex switch. Even now, vstart.sh without the no log dep option still sets the log dep, still turns on the log dep. But on production builds, it's effectless. It has no effect because CEF mutex is perfectly for production builds is perfectly unaware about log dep support. So I made a small patch for our run CBT script. Here it is. I'm going to send this as a PR, but I'm also thinking about putting an assert about asserting OSD when somebody would try to turn log dep on release builds. I think we would need
maybe we can add a warning there if the log dep is
warning assert, something like that.
Yeah, because I have tested analysis RBD performance before, and I found it is low, and the final and I spent a lot of time finally find the log dep costs a lot of time, and when I turn it off, it is okay. So log dep definitely will hurt performance a lot.
Anyway, after I made some additional tests, also with aerator and also with the patches for SeaStor, basically to avoid the future underscore state materialization, and they are worth maybe around 10 to 15%. With them, Vanilla Crimson is able to achieve around 57,000 of cycles per IO. So it's still more than 2 times more efficient than classical OSD in single OSD testing, and 3 times more efficient in let's say contented scenario. 3 OSDs and 2 clients on one machine with 4 physical core is really a contented scenario. Besides of that,
why Crimson OSD has a lot less instructions per cycle to spend, but the final performance is similar? You have some
I meant cycles, not instructions. Cycles. In terms of instructions, we are quite similar. The IPC is much higher in case of Crimson. Instruction per cycle. Does it respond the question you asked?
Yeah, but if IPC is much higher, so it can instructions per cycle, so it can execute much more instructions per cycle, and the CPU cycle is different. Do you mean when the Crimson OSD and classical OSD is running, the cycles are different, so the IPC is different, but the final performance is similar?
Yes, take into account that that classical can use much more CPUs than Crimson. Crimson is always one.
Mm-hmm.
Messenger, in case, even if you are set the number of TPs to 1 and number of messenger threads to 1, you will have 2 cores involved in case of classical OSD.
I mean, there's a simple fix for that for the CBT thing, right? We could just use CPU affinity stuff to force all of the stuff from the OSD process onto the same core. for both. Then it would be
Yes,
truly
but
apples to apples, right?
sure,
If the goal is
but
an even comparison, we should be doing that. It's just easier.
okay, but no, I'm not pretty sure about that will change the metric significantly.
Why not? Your argument is that the classic OSD is able to keep up with even with a lower IPC because it uses more cores. If you force it to a single core, surely it would be CPU limited.
Yes, but I'm not inclined to the absolute number of IOPS I'm seeing. I think that much more important metric is the number of cycles we are burning
I think that's
to handle
we could do both.
single IOP.
I think that could be true too, but let me put it this way. It'll be easier to explain to management if we have a number that says
Okay.
down to one core, Crimson is twice as fast.
Oh, okay.
It's also a
That's-
genuinely useful metric. Like they're both useful, genuinely. Like allowing Classic to use as many cores as it needs to, what's the difference in cycles is one useful thing. And secondly, if we really do force them to the same number of cores, the absolute difference in speed is also interesting.
Okay, but for technical purposes, for development testing, I prefer to stick to cycles per IO. By the way, I
I'd
also
argue that
asked
they're-
Mark to.
I'd argue that they're both
Sorry, please
useful.
continue. Sorry, Mark,
Sure.
could you repeat, please?
I said I would argue that they're both useful because IPC can actually be different depending on how many cores the process is running on. It affects the instruction
Okay.
cache. In other words, Classic might actually perform worse if you force all of its threads onto the same core, right?
Yeah, you will get much more switching because
You'll get a lot.
And that's the case of the FreeOSD scenario. Huge contention. There, Crimson is 3 times more efficient than classical.
Oh, very true. Yeah, we're actually running three of them. We are running three of them on three different cores. That's not the case.
Sorry?
I think that in a three OSD cluster case, we are running three cores, assigning three different cores to three different OSD. So they're not contention in the case of Crimson OSD.
In Crimson, no. Apart from the number of clients, we have 2 Rados benches. Each of them consumes around 1 core.
Oh, yeah.
So there is definitely some contention for Crimson OSD, but a lot of contention for classical OSD.
Yeah.
By the way, I asked
the client are competing the CPU resource with the Crimson OSD.
Yes, Crimson also gets some switching, and I believe that's the reason why it's the IPC while the cycles per IO metric is higher, it's worse than in case of single OSD scenario.
Yes, we could improve CBT in this area to assign the client to different cores used by Crimson OSD. Yeah.
By the way, I asked Mark Nelson to perform some checks on classical, some testing of classical OSD in the domain of cycles per IO, both in MemStore and BlueStore configuration. And it seems that most of this 2/3 of cycles we are burning, that classical OSD we're burning, is located in object store implementation. So in short, the SeaStor will be even more important than the OSD itself, I believe.
Yeah, that's
Yep. The last thing is related is about aerator. I'm trying to optimize the branch to have very minimal impact on performance. What I have at the moment in 4K random read testing is 75,000 and half for vanilla. And 59 for aerator. So it's around the penalty is around two thousands of cycles per IO. After applying all the patches also to SeaStor. And now the question: is it good enough, or we should or I should optimize it more?
To be clear, these are paths. Are these pathways that don't currently have error handling?
Yes, it's on read.
In your opinion, is it likely that this overhead is from aerator or from interacting with the exception portion at all?
It's from aerator, I believe. It's because sometimes we need. I can see two possible paths. First one is that that aerator simply inflates the code base, so we have, for instance, lower cache density. Second thing is that even on hot paths, we have actually some copies, some copying between different types of future. In C++ 17 doesn't provide you any copy elision guarantees for non-same types. So if you are you will get some extra move operations.
So when you are unboxing the vanilla future to and from the civcon part, we're being punished by the non-copy elision version of a copy.
Yep.
Okay.
It will actually be a move operation.
Yeah.
Not full-blown copy, but it still will be.
Yes. Yeah.
If we go the other path and simply wrap, like the union type, even okay. Well, I mean, we have to handle the exceptions, so.
My gut feeling is that it's right.
Are you sure that it's not the additional branches from checking the return status?
I'm pretty sure. I made two things. I selected random read for testing and put just a debug, just as std out printing to ensure the path is not taken. And also I put the error handling path, as I hinted, is it as non-aligned and cold. So this is you should put it in different sections actually of code. So I'm pretty sure that even on error-free path, we still have some overhead. I removed it. I'm able to remove it entirely from things like from ops executor now it's execute OSD up. But we still have some wrapping in PG do OSD ops. It's because passing through the do for each and do with.
Oh, well, we should just create custom versions of those. There's absolutely no reason to pay a penalty on that, right?
Well, I made that with okay, I have a custom version, but it does boxing and unboxing. I can translate the code actually.
Yeah, I mean, it's not that much code. It's not. I think I've looked at those pieces of code. They're really not that complicated.
But it can be also a bit painful because those internal things of SeaStor tends to use some protected, some inaccessible methods of future.
It doesn't seem
So
like
it's not always. It's not all. Well, I'm likely it will work, but what I want to emphasize. It's not a silver bullet.
No, I hear you.
Okay.
I guess the only way to really find out would be to like write the same error handling code without the aerator and see what the penalty is.
Sorry, could you repeat?
What I'm worried that if we write the same error handling code without the aerator, we will still get a significant penalty, if not the same one.
Likely so. I mean?
And if that's true, then what we're measuring is that the code became more complicated because it's less wrong now. And if that's true, then
sorry, Sam, we lost you. At least I.
What I meant was if
cannot hear you.
You're muted.
Oh, how about now? Sorry.
Okay, that works.
All right. I was saying if we're going to pay the same penalty to handle or almost the same penalty even, for just handling it raw using futures and manually doing dynamic casting on the exception type, then we should use the one that's less likely to be wrong. Because in that case, what we're mostly measuring is that the existing code is wrong, right? Because it doesn't handle the errors and we actually have to handle them. So how hard would it be to write code that does handle the errors but doesn't use the aerator? That correctly propagates in events.
Yep, I can. We already had a class, a helper for doing that, but it required using then wrapped on your own. Well,
right, but that's what we're talking about. That's the alternative, right?
Yes.
Because I don't really care about the difference between the aerated version and vanilla. I care about the difference between the aerated version and the fastest correct version.
Okay. Well, the previous version, the very simple, not aerator using one, that's a limitation that is being addressed by aerator. It's chaining of course. It's delegating actually the error handling to some upper layer.
But the upper layer doesn't currently
I
handle
believe
it, right?
that's the part that is costly.
Well, that's okay. If it's delegating it to the layer that's supposed to handle it, that's correct. It's just not statically checked.
Of course, but the delegation, it's costly on its own, because you will have some extra operations because of that.
Okay, and that's built into the vanilla number, or that's a separate thing?
No, it's separated. The vanilla version was unable to do any delegation.
Right. So what I'm worried about is, what do we think is the fastest way to correctly handle these non-success cases? And how does that compare to the error-rated version? Because what we're talking about ultimately here is, if BlueStor or SeaStor throws an enoent on a read, how does the layer above it that's actually trying to build an object context translate that to the layer above that that's actually trying to do a read on an object, right? Because it's not necessarily an enoent back to the user. It might be something like you need to do a cache operation or whatever. So if currently we aren't doing any of those things, or even sending the error case back to the client, then the current code is not correct. So the speed of that is only somewhat interesting. What we really care about is the speed of code that correctly handles all of the cases we need to handle.
I see. We've compiled basically the compile time enforcement of proper handling.
No, I'm not even talking about that. It's okay. Well, maybe it's not okay. But even if it's just dynamic and we have to inspect it by hand, how much penalty is there to handle the exceptions just by manually doing a then wrapped or whatever?
Okay, in that way, I bet it will be very close to vanilla, closer than Aerator.
Okay, so I think that's a worthwhile experiment on at least one pathway.
Okay, we could do that. I prepare some testing.
I'm sorry?
I will prepare some testing for that.
Yeah. Because if it turns out we just can't afford the aerated thing, then we'll leave it alone until we find a better way to do it, right?
Yep.
But a 4% hit just for static checking doesn't seem worth it, honestly. Particularly since we're going to spread this through a lot of code. This is going to be really common.
Mm-hmm.
I don't know. Am I wrong? Do you guys agree?
I think we should focus on the happy path. If we have a like 4% penalty caused by aerator, it's not sounds a good bargain.
Well, I also don't want to hear things like focus on the happy path. Remember, eventually we have to deliver a functioning, working OSD. And 95% of that is the non-happy path. But I agree that it's not worth very much if we gave up 4% of our throughput for static checking. That's a lot.
So what do you mean by non-happy path? I think if we try to return object info and it returns no entry, that's actually expected outcome.
Yes.
So it's
okay. That's fine. In that case, that's part of the happy path, and we have to focus on it.
Yeah.
I'm okay with that phrasing too. That's fine.
Okay. So I kind of agree with you.
But it's also possible that when we do this, that when we actually do write the code required to handle it without the aerator, we find that the penalty is similar. And that will also be an interesting outcome. So I think it's a worthwhile experiment to do.
It's like handcrafted aerator, and we need to take care of all the outcome and.
You just do it by hand and manually inspect it. It's not really that different from the way it works in classic OSD, right? You just have to know what error codes are possible.
Yeah.
But again, it's possible that it's just as bad, right? So we'll see.
Yep, more testing is needed. Also, we could go with more aggressive copy avoidance in Erator at the price of the code duplication. Now the helpers from SeaStor utilities like do for each.
That wouldn't really bother me either, if I'm being honest.
Okay,
it's code duplication, but code duplication of a core library that doesn't change that fast. I mean, it's not that big a deal, in my opinion.
Okay.
Are we ready to move on?
I think so.
Okay. Jen.
Yep. Radek, I linked my current progress on the Crimson object context work up at the top. I expected.
Thanks.
Go ahead. I expect it to be compiling and working sometime middle tomorrow. It almost compiles and works today, but I did a bunch of stuff this afternoon that I haven't finished stabilizing yet. The long and the short of it is I've introduced an intrusive LRU that avoids allocations in the creation, other than the object context structure itself. All of the other tree and list nodes required to maintain the LRU are embedded in the op request itself. And it essentially replaces the cached OSTs pipe. And there's already a cached OST because the object states were cached. This replaces that with an object context, which caches the object state instead. And it also adds a snap context to replace the cached SST for pretty much the same reason. It also introduces locking machinery so that if you've read the primary log PG code, there's a point where it goes through the MOSD op and figures out what requirements the op has. Does it do reads? Does it do writes? Does it do reads and writes? In which case it needs an exclusive lock. And it integrates a blocking lock structure, so that when an op tries to do an operation to an object, it will potentially block if need be, by descheduling in the future and getting woken up later. A lot of the work was extracting the important logic out of primary log PG and OSD, so that we won't duplicate it. And that's it. I'm getting pretty close on that. After that, I'll toggle back to the scheduler work and then back to the backfill recovery work. I figured I'd get this done sooner since Radek needed it for Watch Notify. That's it.
Thanks for the branch.
Mm-hmm. You may want to just leave it alone till tomorrow evening, but if you can also have a look at it either way.
Sure, I will take a look in the background.
And I haven't written test yet for the LRU, so 50-50 it crashes.
Yeah, I have a patch this week. It is still testing, but it's testing different combination of policies regarding to reset, remote reset, standby behaviors. It is also tested in async messenger, and I think the unit test is complete, and is complete at this stage, and so I will start to write the async test peer in the next step, and at the end of this week I will attend another meeting. So yeah. So another question is, I saw that in my PR that the perf test is always pending and there's no details. do you know what's wrong with it, Kufu?
I think we have only a single node for performing the performance make check. I will check if that node is in center 08. I will check if it's blocked, because sometimes the redo bench is a prefill would be blocked forever. I haven't figured out why. Presumably it's a bug or something.
Mm-hmm.
I will log on to that machine and check out the state of it.
Thank you.
And by the way, do you think it's a good idea to support have better support of V2 messenger? I mean the address vector. Currently, we only use a single address in this address vector.
Yeah, but the async messenger will send address vector to chromosome messenger. So in the handshake, the async messenger will send its address vectors to chromosome messenger. So that's why there's a lot of to-dos in the chromosome messenger. So I don't know if there's a way to handle the async messenger address vector properly. If not, I will also add the vectors to chromosome messenger. So that's my plan.
Okay, thank you. I'm checking out the other warnings last week. Seems we still missing that feature in chromosome messenger.
Yeah, sure. Because it needs to make sure that the address is not changed during different doing reconnect. So maybe I think it's better to get all the addresses from the async side. So yeah.
One other thing I forgot to mention. I added some information on ZNS SSDs and persistent memory to the SeaStor doc. But also Josh pointed out something interesting today that I think we should think about. Compression isn't probably that hard to shoehorn in later, but encryption is going to be a weird question. Because encrypting persistent memory is sort of exactly counter to our goals, since we want to be able to return pointers directly into it. So that is an interesting thing we'll want to think about a little bit. That's all I've got.
Thank you. So aside from SeaStor, is there anything that is critical and important we need to look at, so I can prioritize my tasks? Currently, what I have in my mind is the SeaStor RocksDB. The SeaStor BlueStor. But since Chimay had a working alienized version, so I think the priority of it can be lower.
I think that's right. I think we want to get at least a design for SeaStor.
Okay.
Yeah, or at least start fleshing out what we want to prototype.
Okay, cool.
Like I think that the Radix tree or the Radix tree design family is genuinely interesting. And we'll want to find a way to work out whether we can get lower IAP cost for insertions compared to B trees that way. B trees also have their own advantages though, so I think that's an interesting tension we'll want to look at.
Sorry, what back tree? What is it?
I linked a few paper in my or in the thing under the persistent memory section, but they have certain. It's unlike a B tree, the shape is independent of the insertion order. In that you sort of assume keys look like an n-bit key. You partition each. Let's say the first, the root node has the entries corresponding to the first byte, so 256 or whatever possible slots, and so on down the tree. Obviously, for sparse trees, this doesn't work particularly well without some tricks, but the paper has some tricks. The advantage is that you can do insertions into persistent memory with a sequence of 8-byte atomic writes safely. and it'll be crash consistent. It doesn't require rebalancing operations. So it's a potentially interesting concept. And I think that won't be the only one we'll want to look at. So we'll want to look at more papers also.
Yeah. Okay. Any questions? Oh, by the way, Redek, probably I will not look at your aerated branch soon because I think it's depending on the further testing and performance check.
Sure. I'm rectifying the do for each and do with right now.
Okay. Okay.
We'll keep you updated.
Looking forward to better performance.
Yep. I mean,
Okay.
I want to eradicate almost actually all copies I'm aware about.
Yeah. To make sure it's text free.
Yep.
As much as we can. I think that's it. See you next week. Have a good day and have a good night.
Thanks. See you.
You.
Thank you.
Bye.
Bye bye.